Last lesson, we learned about the definite integral and how it represents the area underneath the curve on some interval a to b. Let us say that we know the interval starts at a, some number, but we do not know where it stops. That would give us the interval a comma x, where a is a constant and x is some unknown variable. We can represent that as a new function that looks like this. Capital f of x is equal to the integral from a to x, and then it could be a function lowercase f of t dt. So the x here, the capital F of x, lets us know where we stop from a to x. And then this is a f of t or any other letter. It just can't be an x because we're already using an x over here. So let's do an example here. Let capital F of x equal the integral from 0 to x f of t dt. Use the graph in the figure to find the values of the table on the interval 0 to 5. Complete the table. So if x is 0, what is capital F of 0? So f of 0, capital F of 0 is just the integral from 0 to 0 of f of t dt. And keep in mind, this graph right here is f of t. So just what's the area underneath this curve from 0 to 0? Well, that's just 0 because that's nothing. Let's look at 1. When x is 1, we're looking for integral from 0 to 1 on the curve. So integral from 0 to 1, that's the area beneath the curve from 0 to 1. All this right here. That's 2 squares and then half a square, so that's 2.5. So when x is 2, following the same pattern, replace the 2 here. You find the integral from 0 to 2 f of t dt. It's going to be this entire region now, from 0 to 2. And there's different ways you can calculate this. You can do it as a trapezoid, break it up into squares and triangles, but you end up getting an area of 4. From 0 to 3, you just add on the square of 1, which is 5. And then when x is 4, you just add on this, which is a 0.5. And then from 0 to 5, you are subtracting this area underneath. So it's your area from 0 to 4, and then you're subtracting an area of 0.5. So that gets you to a 5. If you have any confusion with how we got these values here, please let your teacher know for clarification right now. This is also called an accumulation function. So the fundamental theorem of calculus. So if a is a constant and f is a continuous function, then the derivative of an integral is just what's inside. So instead of ft is just f of x. Derivatives and integrals are inverses of each other. They cancel each other out, just like multiplication, division. They're opposites, inverses. In example 1, the graph of f is the derivative of capital F of x. So capital F of x is considered the antiderivative of lowercase f of x. Again, derivatives and integrals cancel each other out. So here are some variations of the fundamental theorem of calculus. So in the original one, it's just from a constant to x. It's just x, right? But if you remember the chain rule, if it's not an x, like a g of x, well, you have to use the chain rule. So derivative of the integral from a to g of x of f of t, it's plug in the g of x for the t, so it's f of g of x, but then you have to multiply by the derivative of g of x, which is just g prime of x. So here now, if you have a derivative from a function to another function of f of t, you can first start by plugging in the top, so f of g of x times g prime of x, and then you subtract, plugging in the h of x into here and using the chain rule, minus f of h of x multiplied by the derivative of h of x, which is h prime of x. So we can do some examples now. You want to find the derivative of each of these functions here. So capital F of x is equal to the integral of 2 dx of 3t squared plus 4t. This one's simple. All you do is plug in the x by itself. So it's just f prime of x is equal to, it's capital F. Plug in the x for t, 3x squared plus 4x. Simple. So question 2. Capital F of x is equal to the integral from pi over 2 to x cubed. So pi over 2 is a constant, but instead of an x, we have an x cubed, so we know we have to use the chain rule. So you can plug in the x cubed into t here, like normal, sine of x cubed, but then you have to multiply by the derivative of x cubed, which is 3x squared. Question 3 right here. You have to use the chain rule again because it's from 1 to 4x. It's not an x, it's a 4x. So f prime of x is equal to h of, you plug in the 4x for t, and then you multiply by the derivative of 4x, which is 4. Question 4 right here. This is the integral from negative x to x. So you have a function on the bottom and the function on the top bound of the integral. So f prime of x is equal to 5. Well, 5, you can put the x for the t, so it's 5x. And you could technically use the chain rule too, because the derivative of x is just 1. So you can multiply that by a 1. It's still 5x. But then you have to subtract, plugging in the negative x, 5 parentheses negative x, and you multiply by the derivative of negative x, which is negative 1. And if you simplify that out, that's just 5x times 1 is 5x. Negative 5 times negative x times negative 1, that's a minus 5x, and you get 0. So this problem right here is following this variation of the fundamental theorem of calculus, the bottom one, if there's a function on the lower and upper bound of the integral. So last example right here before you can start practice is f of x is equal to the integral from 2x to 3x of t squared minus t. So same thing here. You're going to do f prime of x is equal to, plug in the 3x here. So it's 3x squared minus 3x. Again, you're plugging the 3x for the t's. And then you have to multiply by the derivative of 3x, which is 3. Now you subtract, you plug in the 2x for t. So it's 2x squared minus parentheses 2x. And you multiply by the derivative of 2x, which is 2. Now if you want to continue going on with this, simplifying what's inside the parentheses, 3x squared, that's 9x squared minus 3x times 3 minus 4x squared minus 2x times 2. That's equal to 27. So 9x squared times 3, that's 27x squared minus 3x times 3, that's 9x minus 4x squared times 2, that's 8x squared minus a negative 2x times 2, so that's a plus 4x. And that all simplifies to 27x squared minus 8x squared. That is, what is that? That's 19x squared. Negative 9x plus 4x, that is minus 5x. That's it. You can go ahead and start the practice.